Think about the last time you got into your car. You probably didn't spend much time wondering why the seat felt the way it did or why that one button was exactly where it was.
Probably not.
But trust me, a huge amount of thought goes into all of that, way beyond just making it look good or, the engine run smoothly.
Absolutely. And that's precisely what we're diving into today. The fascinating, often invisible world of automotive ergonomics.
Right.
Our guide for this exploration is the comprehensive book Ergonomics in the Automotive Design Process by Vivek Bhise.
Okay, so our mission today is to unpack the key human factors that shape how a vehicle is designed.
Yeah.
We're not just scratching the surface of aesthetics or horsepower. We're going deep into the underlying science and engineering that aims to make your time behind the wheel safe, comfortable, and maybe even, well, a little bit enjoyable.
Or even delightful sometimes.
Yeah. Think of it as getting the inside scoop on why certain things in your car just feel the way they do.
And this is a comprehensive look. The book we're exploring covers an incredible range, from the basic measurements of the human body to how our brains process information while driving, and even the subtle feel of the materials inside the car. So, let's get started.
Okay, so let's start with the basics. When we talk about automotive design, what exactly is ergonomics?
In simple terms, ergonomics is the science of making things work well for people.
Right.
It's about understanding how humans interact with systems, in this case, a car, and then using that knowledge to design those systems to optimize our well-being and overall performance.
Right.
You might also hear it called human factors engineering or human engineering.
Okay.
Essentially, it's about fitting the task of driving to the driver and passengers.
And it's not just about how our bodies fit in the seats, right?
Yeah.
There's more to it than that.
Exactly. There are two main sides to it. First, there's the physical side, which deals with how our bodies, our bones, muscles, and posture interact with the car's physical components like the seats, pedals, and steering wheel.
All right, the biomechanics.
Precisely. And second, there's the mental side, which looks at how we take in information, make decisions, and react while we're driving. Information processing.
It feels like this would be a really important area for car companies these days.
Oh, it's increasingly crucial. The auto industry is highly competitive, and companies are always looking for ways to stand out. Ergonomics helps them do that by contributing to things customers really care about. How functional the car is, how comfortable it is on a long drive,
Yeah.
how convenient the controls are, how safe it feels, and even the overall sense of quality and craftsmanship.
Right, that feel.
Getting the ergonomics right can really make a difference in customer satisfaction.
Has this always been a big focus for the auto industry? What's the history behind it?
It's interesting. The formal fields of human factors and ergonomics really took off after World War II.
Sure.
In the US, there was a lot of focus on the mental side, often driven by psychologists working on military equipment. In Europe around the same time, the focus started to be more on the physical aspects and improving industrial workplaces.
Right.
The term ergonomics itself comes from Greek words meaning work and laws.
Oh, interesting.
Over time, the terms human factors and ergonomics have become pretty much interchangeable, covering both the mind and the body.
And when did car companies start paying more attention to this?
Well, the U.S. auto industry really started to ramp up its focus on both fuel efficiency, aerodynamics,
Right.
and comfort and convenience, ergonomics, after the fuel crisis in the 1970s.
Oh,
Funny enough, the similar sounding terms even had a bit of a marketing buzz back then.
Huh. Okay, so how do these ergonomics experts actually go about their work? What are their main ways of figuring out what works best?
They typically use a mix of three main approaches. First, they rely on existing knowledge and data, things like databases of human body measurements or models of how people react to stimuli, anthropometry, that kind of thing.
God.
Second, they conduct experiments to test how different design elements affect users.
Like usability testing.
Exactly. And third, they evaluate existing designs to see how well they perform in terms of user experience and preference, comparing things.
Okay.
It's usually a combination of all three that gives them the best insights.
That makes sense. You wouldn't want to just guess. You'd want to back it up with data and real-world testing.
Precisely.
What are some of the specific things these engineers do day to day?
Well, they're involved right from the start of the vehicle design process.
Really early on.
Oh, yeah. They participate in design meetings, give input on the layout of the interior and the functionality of different features.
Okay.
They also play a big role in looking at customer feedback, things like complaints, warranty claims,
Oh,
and those customer satisfaction surveys you see, like the JD Power surveys.
right, right.
And to keep track of how the ergonomics of a vehicle are progressing, they often create ergonomic scorecards at different stages of development.
Like a report card for comfort and usability.
Sort of, yeah. It helps track progress and identify issues early.
It's amazing to think about all the behind-the-scenes work that goes into making a car feel intuitive. Were there any key moments in the history of making cars more human-friendly?
Definitely. Early on, the Society of Automotive Engineers, the SAE,
Mm-hmm.
started setting standards for things like vehicle lighting way back in the 1910s and 20s.
Wow, that early.
Yeah. And a big step was Ford creating a dedicated human factors engineering department in 1956, showing they recognized the importance of this.
That's significant.
Later, in 1965, the SAE came out with the ILIPS standard.
Oh, what now?
The ILIPS. It basically defined the range of where a driver's eyes are likely to be.
Ah, okay.
And that was huge for designing good visibility.
I can imagine.
And of course, the safety regulations that came out in 1966 really highlighted how important human factors are for keeping drivers safe.
Okay, let's get into the nitty-gritty of design then. The book talks about starting with the human body itself. How do they even begin to think about designing something that will work for so many different shapes and sizes of people?
That's the fundamental first step. They have to understand who their target users are and what their physical characteristics are.
Right.
This involves gathering what's called anthropometric and biomechanical data.
Anthropometry.
Yeah.
That sounds very technical. What does that actually mean for car design?
Essentially, it's the science of measuring the human body.
Yeah.
Things like height, weight, how long your arms and legs are, the size around your chest, and so on.
Uh-huh.
By collecting this data from large groups of people, engineers can understand the range of body dimensions they need to accommodate in a vehicle.
And how does biomechanical data fit into this picture?
Biomechanics looks at how our bodies move, how much force we can exert, and what our comfortable ranges of motion are. This helps designers make sure that using the car, things like pressing the pedals or turning the steering wheel, doesn't require excessive force or put our bodies in awkward or straining positions.
Okay.
While you don't see the same kind of repetitive strain injuries in driving as you might in some factory jobs, these principles are still key for making a car comfortable and convenient to use.
I've heard designers talk about things like the 95th percentile. What does that mean when they're talking about designing a car?
Percentile values are a way to design for a large majority of the population.
Okay.
For example, the 95th percentile for male height is about 1,855 millimeters, or just over 6 feet 1 inch.
Right.
That means only about 5% of adult males are taller than that. So if you're designing a car door opening,
Uh-huh.
making it at least that high plus a little extra for shoes and movement means that 95% of men will be able to walk through it without having to duck too much.
Ah, I see.
It's about designing for the extremes to cover most of the people in between.
So it's about designing for the really tall or the really short to make sure everyone else is comfortable.
Exactly. And for those who are curious about the numbers, statisticians use standard methods based on the normal distribution to calculate these percentile values.
Okay.
It allows designers to say, we want to accommodate, say, 90% of the population for this particular dimension, and then they can look up the corresponding percentile value to design for.
That's helpful to picture. But we don't just sit like mannequins in our cars, do we? We move around.
You're absolutely right, and that's a limitation of just using static body measurement.
Right.
When we're driving, our posture is constantly changing as we reach for controls, look around, or adjust our seating position.
Mm.
That's why engineers also collect data on people actually interacting with vehicles, looking at things like comfortable reach distances and how our body angles change while driving. This functional anthropometry is really crucial for designing a car that works well in the real world.
Okay, let's dig a little deeper into those biomechanical considerations. What specific parts of the car's design are really influenced by how our bodies move and exert force?
Quite a few things. Take the seat cushion length, for example.
Mm-hmm.
If the cushion is too long, it can put pressure on the back of your legs and restrict blood flow, which can be uncomfortable.
Right, I've felt that.
Shorter cushions are generally better as they allow for more movement.
Okay.
Foot support is another big one. If your feet are just dangling, it can strain your lower back, so providing a place to rest your heels is important.
Mm.
Similarly, seat cushion and seat back curvature play a role. Heavily contoured seats might seem supportive initially,
Yeah.
but they can actually restrict movement and lead to fatigue on longer drives. Flatter or less curved surfaces allow for small shifts in posture, which helps keep you comfortable.
That's interesting. Kind of counterintuitive.
It can be. You need some freedom to move.
What about how high the seat is and the angle of the seat back? Those seem pretty important for comfort.
Definitely. Seat height, often referred to by engineers as the H30 dimension,
Very
really affects your overall driving posture. If the seat is too high, especially for shorter drivers, their feet might not reach the pedals comfortably.
Right.
The goal is to have a seat height that's comfortable for a wide range of leg lengths. That's one reason why power seats with height adjustments are so valuable. Seat back angle, or what's called A40,
A40.
is the angle of your upper body relative to being straight up and down. For most passenger cars, people tend to prefer a slight recline, typically between about 20 and 26 degrees.
Okay, 20 to 26 degrees. Got it.
Yeah, that seems to be the sweet spot for many people.
So once you have a good understanding of human dimensions, how do you actually fit people and all the mechanical and electronic systems of a car together? It sounds like a complicated puzzle.
That's exactly what occupant packaging is all about. It's a process of figuring out how to best allocate the space inside the vehicle for all the essential components, the engine, the air conditioning, the fuel tank.
Right, all the guts.
As well as the people and their stuff. Luggage space, storage bins, all that.
And what are the main things they have to keep in mind when they're trying to package the occupants?
The key things they consider are how the driver and passengers will sit, their posture, how easily the driver can reach and operate all the controls, how well everyone can see both inside and outside the car. Visibility is huge.
Yeah.
How easy it is to get in and out, ingress and egress, they call it.
Right.
The overall comfort during the ride, and crucially, how safe the occupants will be in case of a collision.
Okay, safety is paramount.
Always.
So how does all this get translated into the actual design of a car?
The vehicle development process involves a lot of different teams working together, stylists who focus on the look, designers who work on the overall layout and functionality, engineers who deal with the mechanical and electrical systems, and researchers who study things like ergonomics. Package engineers have a central role in taking all these different inputs and creating the initial layout of the vehicle using computer-aided design, or CAD, systems.
CAD, okay.
They're constantly making trade-offs and trying to find the best compromise between all the different requirements. It's a real balancing act.
You mentioned the seating reference point earlier.
Yeah.
What exactly is that, and why is it so important in vehicle design?
The seating reference point, or SGRP for short,
SGRP.
is a really important theoretical point in the car's design. Think of it as representing the pivot point of a person's hips when they're sitting in a normal driving position.
Okay, like a hip point.
Exactly. It's used as a consistent reference for defining many other key interior dimensions and ensuring that measurements are comparable across different vehicles and even different manufacturers. It's a standard benchmark.
And how do they decide how far the seats need to be able to slide back and forth at seat-track travel?
Seat-track travel is largely based on studies of where drivers actually position their seats when they're comfortable.
Ah, real-world data.
Yes. There is an SAE standard, J517, that provides guidelines based on statistical predictions of where different percentile drivers, from the very small to the very large, will want their seats to be. They often look at the 2.5th percentile, very small, and the 97.5th percentile, very large H-point locations.
H-point.
Another reference point, very close to the SGRP. They use these extremes to determine the minimum and maximum seat positions needed to accommodate, say, 95% of drivers.
Okay, that makes sense. Let's talk about some of those specific measurements inside the car. I see some letter number combinations in our notes, like H61 and L33. What do those mean?
Those are part of a standardized system for defining vehicle interior dimensions called SAE J1100.
Ah, the SAE standards again.
Exactly. It's like a common language for engineers to talk about space inside the car.
Oh.
For example, H61 refers to the effective headroom, the vertical distance from that seating reference point up to the headliner, plus a little extra.
Got it. Headroom.
L33 is the legroom, which is the distance from the SGRP back to where your ankle pivots, plus a bit more. Then you have things like W3 for shoulder room, W31 for elbow room, a W5 for hip room,
All the widths?
and L62 for knee clearance, which is the minimum space between your knee and anything it might bump into, like the dashboard.
Right.
These standard measurements make it much easier to compare and ensure adequate space for occupants.
And what about being able to see out of the car? I saw head clearance envelope eyelips mentioned. That sounds important.
The head clearance envelope, also known as the eyelips,
Eyelips, right.
and defined in SAE J1052, represents the three-dimensional area where a driver's eyes are likely to be located.
A 3D zone.
Exactly. It takes into account the range of head and body positions for different sized people and different seat adjustments.
Okay.
Engineers use this to make sure there's enough headroom and that the driver has a clear line of sight over the steering wheel and through the windshield. The standard even considers how people might tilt their heads sideways or downwards.
Wow, detailed. And finally, how do they make sure all the buttons and knobs are easy for the driver to reach?
That's where data on maximum hand reach provided in SAE J287 comes in.
Another standard.
Yep. This is based on studies where people sat in car mock-ups and reached for different simulated controls. The data gives engineers information about how far people can comfortably reach in different directions. This helps them define comfortable reach zones for placing frequently used controls so the driver doesn't have to strain or lean too much.
Okay, so keeping things within easy reach.
That's the goal.
This is all about the physical interaction, but driving is also a very mental task.
Mm-hmm.
How does ergonomics factor in how drivers take in and process information?
That's a crucial part of the puzzle. A basic way to think about how we process information is in 4 stages.
Okay.
First, we take in the information like seeing a stop sign, stimulus encoding.
Right.
Second, our brain processes what that information means, central processing.
Mm-hmm.
Third, we decide what to do, in this case, hit the brakes, response selection. And fourth, we actually carry out that action moving our foot, response execution. Each of these steps takes time.
Right.
And the more complex the situation, the longer it takes.
So how quickly we can react, our reaction time is a big deal.
Absolutely. Reaction time isn't just one thing. It has several parts. There's the time it takes for our eyes to see the stop sign, the receptor delay, the time for that signal to travel to our brain, transmission time, the time our brain takes to figure out what to do, central processing time, and then the time it takes for our muscles to actually move our foot to the brake pedal, the motor response time.
Lots of steps.
Yes. There's also something called the psychological refractory period,
Okay.
which is a brief delay in reacting to a second thing if it happens right after the first. It suggests our brain deals with information in a sequence to some extent.
Yeah.
Can't quite do 2 things instantly at once.
And I saw something about simple versus choice reaction time. What's the difference there?
Simple reaction time is when there's only one possible thing that can happen and only one way to respond.
Like hitting a button when a light turns on.
Exactly. Choice reaction time is when there are multiple things that could happen, and you have to choose the right response.
Like pressing different buttons for different colored lights.
Precisely. As you might expect, having to make a choice usually takes longer.
And Hicks' law. That sounds like something from science class.
Chuckles slightly.
This.
It does, but it's about psychology in this case. Hicks' law explains the relationship between how long it takes to make a decision and how many options you have.
Okay.
It basically says that the more choices you have, the longer it will take you to decide.
Makes sense.
It's not a straight line, though. It increases logarithmically, which means the increase in reaction time gets smaller as you add more and more options.
Oh, okay.
But still, the more buttons or menu items a driver has to consider, the longer it might take them to react to something important on the road.
That makes perfect sense, especially with all the different controls and screens in modern cars.
Definitely.
What else can affect how quickly we can react while driving?
Lots of things. How clear or noticeable the stimulus is, a bright flashing light will get your attention faster than a dim one.
Right.
Your expectations also play a role. If you're expecting something to happen, you'll usually react faster. How mentally or physically tired you are, how stressed you are, how much practice you've had with particular task, and even your age can all influence your reaction time.
Age, right.
For instance, older drivers tend to have slightly slower reaction times, generally speaking.
Now, Fitt's law of hand motion.
Yeah.
Is that related to Hicks' law in some way?
They both deal with time, but Fitt's law is about the physical act of moving your hand to a target, like reaching for a control on the dashboard.
The movement itself.
Yes. It says that the time it takes to move your hand depends on 2 things. How far you have to move and how big the target is.
Distance and size.
Exactly. The further away it is, or the smaller it is, the longer it will take and the more difficult it will be. So, to make it easier to use a control while driving, you want to place it relatively close to the driver and make it a reasonable size. Seems obvious, but there's a formula for it.
Okay, our brains aren't just reacting. They also have to remember things while we're driving. How does our short-term memory, our working memory, come into play here?
Working memory is like the temporary storage in our brain where we hold and work with information for a short period. It has a limited capacity. A classic idea is that we can hold around 7 plus or minus 2 things in our working memory at once.
The magic number 7.
Kinda, yeah. To keep that information active, we need to actively rehearse it, like repeating a phone number to ourselves.
Right.
This is important in driving when we need to remember directions or hold on to temporary information about traffic conditions. If we overload our working memory, it can lead to errors.
It sounds like there's a lot going on in our heads when we're behind the wheel.
There really is.
What are some of the common kinds of mistakes drivers make that ergonomics tries to help prevent?
Driver errors can happen at any stage of that information processing model we talked about.
Okay.
We can have perception errors, where we don't see something clearly or misinterpret it. Comprehension errors are when we misunderstand a situation or a sign. Memory errors are things like forgetting to check our mirrors. Decision errors involve making the wrong choice. Action errors are when we physically do something incorrectly, like hitting the wrong pedal.
Right.
And stress can also lead to errors. Some specific examples might be misreading the tachometer as the speedometer,
Oh, yeah.
forgetting to signal a turn, or accidentally pressing the wrong button on the radio. You also see errors of interpretation, errors where we forget to do something altogether, omission errors.
Okay.
And errors where we do something we shouldn't have, commission errors, like an extraneous act.
Wow. Lots of ways to mess up.
Unfortunately, yes. Which is why good design is so important.
And seeing clearly is obviously vital for driving.
Yeah.
What are some key aspects of our vision that ergonomics experts think about?
Absolutely. How well we can distinguish objects from their background, that's contrast sensitivity, and how sharp our vision is for details, that's visual acuity, are fundamental. That 20/20 rating is a measure of acuity.
Right.
There are also contrast threshold curves that help predict what we can see under different lighting conditions.
Okay.
Our field of view, how much we can see around us without moving our eyes, is also critical. We have different types of vision that are dominant in different lighting. Photopic for bright daylight, mesopic for dusk and dawn, and scotopic for nighttime.
Okay. Day, twilight, night.
Pretty much.
Yeah.
These rely on different cells in our eyes, cones for sharp color vision and good light, found mostly in the center, the fovea,
Cones for color.
and rods for peripheral vision,
Yeah.
and seeing in low light, more numerous in the periphery.
Rods for dim light. Got it.
Yeah.
I've heard that our eyesight changes as we get older. How does that affect driving and how cars are designed?
That's a really important consideration. As we age, it often becomes harder to focus on things that are close up.
Presbyopia.
Exactly, which can make reading dashboard displays difficult, especially if you wear bifocals.
Ah, the bifocal problem.
Right. Bifocals have different areas for seeing near and far, and the angle you look through them can be awkward for viewing certain parts of the dashboard or maybe displays mounted up high. Head-up displays, which project information onto the windshield as if it's out on the road,
Yeah, those.
can be a really helpful solution for older drivers as they don't require shifting focus as much between near and far.
Okay, that makes sense. What about how we actually look around while we're driving? Do ergonomists study that?
Yes, they look at our visual search behavior, which
Yeah.
involves a series of fixations,
Fixations.
where our eyes focus on a specific point for a short time, maybe a fraction of a second,
Okay.
and saccades, which are the rapid movements our eyes make between those fixation points.
The jumps.
Exactly. Understanding these patterns helps in designing instrument panels and placing important information where drivers are most likely to look.
It's a little scary to think about how quickly things can happen and how much we depend on constantly looking at the road. I think I saw something about time away from the road in our notes.
Right. Studies have shown that even when the road is empty, drivers tend to only look away from the forward view for very brief periods.
How brief?
Around 2 seconds when traveling at 70 miles per hour, maybe 4 seconds at 25 miles per hour on an easy road.
Okay.
But in more challenging driving situations with traffic and other demands, that time drops to around just 1 second.
1 second. Wow.
These very short time limits are crucial to keep in mind when designing any in-car tasks or displays that might take the driver's eyes off the road, even for a moment.
Definitely. And it's not just about what we see, is it? We also get information through our other senses when we're driving,
Absolutely. Sound, vibration, touch, and even smell can give us important cues about what's happening with the vehicle and our surroundings.
like engine noise.
Exactly. The sound of the engine can give us a sense of our speed, or a change in how the car feels through the seat or steering wheel can indicate a problem.
Hmm.
However, these sensory inputs can also be negative if they're too loud, too distracting, or unpleasant, like annoying rattles.
Right.
Our hearing, for example, can typically pick up sounds between 20 and 20,000 hertz.
Okay.
But we're most sensitive to sounds in the 500 to 2,000 hertz range, which is important for designing effective warning sounds and alerts that really grab our attention.
So with all this understanding of how we see, think, and react, how do designers actually create the driver interface, the controls, the displays, the whole layout of the cockpit?
The overarching goal is that all the controls and displays should work together seamlessly as a system.
Assist, okay.
This means a logical arrangement, clear and consistent labeling so you know what everything does, controls that move in the way you expect them to,
Uh-huh.
and grouping related functions together. Make it intuitive.
What are some of the different kinds of controls we find in cars these days?
You have continuous controls like a volume knob that you can turn smoothly through a range.
Right.
Then there are discrete controls like buttons for specific fan speeds, low, medium, high.
Okay.
Push buttons are really common now, especially with electronic systems, as they can be relatively inexpensive.
Mm-hmm.
However, making sure they're easy to find and press accurately without looking can be a challenge.
Touch screens, too.
Exactly. Touchscreens are becoming increasingly popular, offering a lot of flexibility and saving space, but they really need good visual, auditory, or even tactile feedback, like a little vibration or click,
Tap that feedback.
so you know you've actually activated something.
Right.
And then you still see a lot of other types of controls like rotary dials, rocker switches, toggle switches, sliders, levers, and joysticks, each with their own pros and cons.
And what about the displays that give us information? Those have changed a lot, too.
They really have. Displays can be analog with needles and gauges,
The classic look.
or digital, showing numbers and text. Some have fixed scales, while others use a moving pointer.
Mm-hmm.
They can be graphic, using pictures and icons, or alphanumeric, using letters and numbers. One challenge with icons or symbols is making sure they're universally understood.
Yeah, sometimes they're confusing.
They can be. Displays can also be dedicated to showing just one thing or be programmable to show different information depending on what's happening.
Right, like the center screen.
Exactly.
Yeah.
And of course, you have the difference between traditional head-down displays in the instrument panel and head-up displays that project information onto the windshield.
HUDs again?
For head-down displays, it's generally best if they're not more than about 30 degrees below your normal horizontal line of sight. Keeps glances shorter.
Okay, 30 degrees down max. Are there some general rules or guidelines that designers follow when they're laying out all these controls and displays?
Yes, there are several key principles. Standardization is important. Controls and displays should behave in ways that drivers are used to from other vehicles, if possible. Feedback is essential. The driver needs to know that when they press a button or turn a dial, something has actually happened.
Right, confirmation.
Clear and concise labeling is crucial. And location is key, considering how easily the driver can reach everything, those reach zones we talked about, and making sure that important information is visible without being blocked by the steering wheel rim or spokes or other parts of the car. Sight lines are critical.
How do they decide where to put everything? What are the main things they think about when they're positioning controls and displays?
Several factors guide their decisions. The importance of the function-critical safety controls should be the easiest to reach and operate.
Like hazard lights.
Exactly. How often a control is used, frequently used ones like volume or climate controls should be more conveniently located than, say, the glove box release.
Right.
The sequence of use, if you typically use two controls one after the other, they should ideally be placed near each other. Functional grouping controls that do related things, like all the climate controls, should be clustered together.
Okay.
And the relationship between a control and the display that shows its effect. For example, the button for the radio station should ideally be near the display that shows the station. Control display compatibility.
Yeah.
Following these principles helps make the interface more intuitive and less cluttered, reducing the mental effort needed.
I can imagine it'd be really confusing if all the buttons felt the same.
Yeah.
How do they help us tell them apart without having to look closely?
That's where cues and coding come in. They use differences in the shape, size, color, texture,
Texture, yeah.
and even the sound or the amount of force needed to activate a control to help us distinguish them by feel. Tactile coding.
No.
For really important functions, like hazard lights, they might even have redundant or alternative ways to activate them.
Like voice commands.
Yeah, exactly. Like some cars might have a dedicated button as well as a voice command. This can be particularly helpful for people with visual or physical limitations or just as a backup.
It's interesting that even something as seemingly simple as a car's interior is based on so much research. You mentioned research on pilot errors earlier. How did that influence car design?
The early studies on pilot errors after World War II were really groundbreaking.
Yeah.
They showed that even highly trained people make mistakes when the equipment they're using isn't designed well for human capabilities and limitations.
Right.
Analyzing those mistakes led to a big focus on designing aircraft cockpits with human factors in mind, things like the layout of controls, the clarity of instruments, minimizing potential confusion. Those same principles directly apply to automotive design. Understanding how drivers might make errors and designing the interface to minimize those risks is crucial for safety, preventing errors before they happen.
And how do they actually judge whether a particular control or display design is good?
They use a variety of methods. They might use checklists that cover things like how easy a control is to find, identify, understand, reach, and use.
Yeah.
These checklists often have scoring systems so they can compare different designs objectively. Ergonomists also create summary charts, sometimes using visual aids like smiley faces or color coding.
Smiley faces. Really?
Yeah, sometimes. To give a quick overall assessment of how user-friendly the interior is at a glance during development reviews.
Okay. Being able to see clearly while driving is obviously non-negotiable for safety. How does ergonomics ensure we have an adequate field of view?
Ensuring good visibility involves a lot of factors, both what you can see directly through the window
Correct vision?
and what you can see indirectly through the mirrors, indirect vision.
Right.
They consider things like where the driver's eyes are likely to be, that eye lips we talked about, how much the car's structure, things like the ABC pillars that hold up the roof, the header above the windshield, the cowl at the base of the windshield might block the view.
Pillar blind spots.
Exactly. And even the placement of interior components like the steering wheel and headrests, as well as exterior elements like the size and position of the mirrors and windshield wipers, it all interacts.
I've noticed sometimes the side mirrors seem to show things at a slightly different angle than I expect.
Yeah.
What's the deal with seeing with one eye versus both eyes in this context?
Our left and right eyes each have a slightly different view of the world, and our brain combines those two views to give us depth perception. That's binocular vision.
Okay.
What each eye sees individually is monocular vision. When you're looking through a car window, there might be something that's blocked from your left eye's view by a pillar, but still visible to your right eye, so your overall binocular view might still be clear. The pillar seems less obstructive with two eyes.
Oh, okay.
With mirrors, it's a bit different. You have the view you get from each mirror individually, monocular, and then the area where the views from both mirrors overlap, binocular mirror field. That overlapping area gives you some depth perception in your side views, but it's not as strong as direct binocular vision.
So are there specific rules or guidelines for designing car mirrors?
Yes, there are guidelines that cover things like the size and shape of the mirror, where it should be positioned relative to the driver's likely eye location, usually the 5th percentile female eye location to ensure smaller drivers can see, how much it needs to be able to adjust, the aim range, and even how its shape might affect wind resistance and noise. For example, the top edge of the side mirror needs to be low enough that it doesn't block the driver's direct view out the side window.
I saw a mention of polar plots for looking at visibility. What are those?
Polar plots are basically a visual way to map out how much you can see from the driver's seat.
Like a chart?
Yeah, sort of a circular chart. They show the angles of visibility, both horizontally and vertically, and they can help engineers identify any blind spots or areas where the driver's view is obstructed by the car's structure. They overlay the pillar locations and see the blockage.
Okay, useful tool. What about the car's glass itself? Does that have an impact on how well we can see?
Absolutely. How much light the windshield and windows let through the light transmissivity affects how clearly you can see, especially at night or in poor weather.
Right.
There are regulations, like FMVSS 205 in the US, that set minimum standards for light transmission to ensure drivers have adequate visibility.
Yeah.
Things like the type of glass, how thick it is, any tinting, and the angle at which it's installed can all play a role.
And with all the new technology like backup cameras and blind spot monitoring, are those considered part of the ergonomics of visibility?
Definitely. These camera and sensor systems are increasingly being used to enhance visibility, especially in situations where direct or indirect vision might be limited.
Like backing up.
Exactly, or changing lanes. They provide the driver with extra information and warnings, which contributes to a safer and more comfortable driving experience. They supplement natural vision.
It sounds like making sure the driver can see properly is something they have to get right very early in the design process.
Yeah. That's absolutely correct. Visibility problems are very hard and expensive to fix once the basic design of the car's structure, the pillars and roofline, is set.
You can't just move a pillar later.
Not easily. Major changes usually have to wait for a whole new model, which is why getting it right early on, using tools like the ellipse and CAD analysis, is so critical.
Let's switch gears and talk about another crucial aspect of driving. Lighting. It's not just about the driver being able to see, but also about the car being visible to others.
Right.
What are the ergonomic considerations for automotive lighting?
Designing and evaluating car lighting is really a system-wide challenge.
Okay.
It involves understanding the driver's needs, the capabilities of the lighting system itself, and the different driving environments.
Right.
Everything from well-lit city streets to dark rural roads and various weather conditions. The goal is to provide enough light for the driver to see hazards in time to react, while also making sure the car's lights clearly signal its presence and intentions to other road users without causing excessive glare.
What are the different types of lights on a car that they have to think about from an ergonomics perspective?
They look at several categories. Exterior lights for helping the driver see include the headlights.
Right.
Exterior lights for signaling to others include brake lights, turn signals, hazard lights, reverse lights.
Yeah.
Interior lighting is important for tasks inside the car, like reading maps or finding things, and for general ambiance and comfort. And then there are other specialized lights like those in the trunk or under the hood for maintenance.
Let's focus on headlights for a moment. What are the main ergonomic goals they're trying to achieve with those?
The main goal of headlights is to illuminate the road ahead far enough so that the driver can spot potential dangers at night and have enough time to react. Seeing distance is key.
Okay.
Low beams are designed to provide enough light for seeing the road without blinding oncoming drivers.
The cutoff.
Exactly, that sharp cutoff. While high beams give you a much longer and wider view when there's no other traffic. Advancements in technology like HID, high-intensity discharge, and especially LED headlights have significantly improved how well headlights perform in recent years. Much brighter and more controlled beams.
You mentioned something earlier about photometric measurements. What are those, and how do they relate to designing car lights?
Photometric measurements are how we quantify light. Luminous flux, measured in lumens, is the total amount of light a lamp puts out.
Lumens, okay.
Luminous intensity in candela is how concentrated that light is in a particular direction. Think of it like the punch of the beam.
Can't tell why.
And illumination, or illuminance, in lux or foot candles is how much light actually falls on a surface, like the road or a sign some distance away.
Lux, okay.
Regulations like FMVSS 108 in the U.S. set specific minimum and maximum values for luminous intensity, candela, at different points in the light beam pattern to make sure headlights provide adequate visibility down the road and to the sides without causing too much glare upwards towards oncoming drivers.
Headlight glare can be a real problem for oncoming drivers.
Yeah.
How do they try to minimize that while still providing good illumination?
Glare can be really bothersome and can even temporarily reduce your vision.
Yeah.
There are two main types. Disability glare, which actually makes it harder to see past the light source.
Okay.
And discomfort glare, which is just annoying and can cause eye strain and fatigue over time. Factors like how bright the light source is, intensity, the angle at which it hits your eyes, and the brightness of the background all play a role.
Right.
Engineers use those photometric measurements and computer models to carefully design the shape and direction of the headlight beam, the reflectors and lenses, to provide good visibility down the road for the driver without shining too much light directly into the eyes of oncoming traffic. It's a careful balance.
Evaluating how well headlight systems work sounds pretty complex, given all the different conditions you might drive in.
Yeah.
How do they do that?
It is a challenge. They use a combination of methods. They do static tests in labs to measure the light output and beam pattern against the regulatory requirements.
Okay.
They conduct on-road tests in real-world driving conditions, often with panels of drivers giving subjective ratings.
Uh-huh.
They also use laboratory studies where they can control things more precisely, maybe using simulators.
Mm-hmm.
And increasingly, they're using computer modeling and simulation to predict how well headlights will perform in different scenarios, even taking into account things like driver age and how well their eyes can see. These models can estimate seeing distance under various conditions.
What about the lights on the back of the car, like brake lights and turn signals? Are there ergonomic considerations for those too?
Absolutely. How bright and what color those lights are and how quickly they come on are crucial for effectively communicating your intentions to other drivers behind you.
Right, reaction time again.
Exactly. Research has looked at things like how quickly drivers react to brake lights of different intensities and whether the color of the turn signal red versus amber affects how quickly it's noticed.
Mm-hmm.
There have also been studies on how effective that center high-mounted stop lamp, CHMSL, has been in reducing rear-end collisions. Seems it has helped.
Yeah, the third brake light.
And looking to the future, there's research into new lighting technologies like light pipes for more uniform appearance and even new ways for the car to signal information to others, maybe beyond just simple on-off signals.
Interesting. Getting in and out of a vehicle seems like a pretty basic action, but I bet there's more to it from an ergonomic standpoint.
Oh, definitely.
What are some of the common complaints people have about getting in and out of cars?
You're right. It's something people often take for granted until they encounter a vehicle that makes it difficult. Common complaints include banging your head on the roof or door frame,
Ouch.
the door not opening wide enough, having to step over a really wide or high sill, that's the rocker panel at the bottom of the door opening,
Right.
not having enough space for your knees as you get in or out, especially swinging your legs in,
Mhm.
or the seat being at an awkward height relative to the ground outside the car, making it hard to slide in or stand up out of.
What are the key body measurements that influence how easy or difficult it is to get in and out of a car?
Several body dimensions are important here, including your hip height when standing, shoulder height, the width across your thighs when sitting,
Okay.
and the distance from your rear end to your knee, your buttock knee length. Designers use this anthropometric data to try and create door openings and seating positions that provide enough clearance and allow for comfortable movement for a wide range of people.
Are there any specific design features that can make getting in and out of a car easier?
Yes. A shorter width for that lower part of the car body, the rocker panel or sill,
Okay.
can make it easier to step over.
Right.
Also, making sure the bottom edge of the door opening itself, the door edge height, is high enough off the ground so you're not tripping over the rocker panel is important. Sometimes, clever designs of the rocker panel itself, maybe making it angled or lower profile, or even having the door extend down slightly to cover it, can make a big difference.
I think I saw task analysis mentioned in relation to getting in and out of a car. What does that involve?
Task analysis is a method ergonomists use to break down a complex task into its individual steps,
Okay.
to identify potential problems or areas where users might struggle. So for getting into a car, they might look at each step. Opening the door, positioning your body, putting one foot in, swinging your legs in, ducking your head, sitting down.
Right.
By analyzing each of these subtasks, they can anticipate where people might encounter difficulties, like not having enough room to swing their legs or having to bend over too far, and then try to design solutions.
Has there been any research comparing how easy it is to get in and out of different types of vehicles?
Yes, there have been studies that have looked at this. One study, for example, compared how older and younger drivers found it to get in and out of a sedan, a minivan, and a pickup truck.
And what do they find?
Generally, the minivan was rated as the easiest, likely due to its higher roofline, often a higher seating position, which means less bending down and sliding doors on some models.
Okay.
Interestingly, even though the minivan was rated easiest, the actual time it took to get in wasn't always the fastest,
Okay.
possibly because people felt they could just step right in without as much careful maneuvering. The sedan, with its lower roof and seat height, sometimes had the longest exit times, suggesting people had to exert more effort to push themselves up and out.
We've talked a lot about interacting with the inside of the car, but what about things like opening the hood or filling the gas tank? Are there ergonomic considerations for those exterior tasks as well?
Absolutely. Common tasks that involve interacting with the exterior of the vehicle include checking and refilling fluids in the engine compartment and, of course, refueling the car. Service and maintenance tasks.
Let's take opening the hood as an example. What ergonomic factors do designers need to think about there?
Opening the hood typically involves finding and operating a release lever inside the car, usually down by the driver's left knee,
Right.
and then usually finding and releasing a secondary safety latch under the front edge of the hood itself. Making sure that inside release is easy to find and pull, and that second latch is easy to see and reach without getting your hands dirty,
Yeah.
is important. The weight of the hood and how much effort it takes to lift it, as well as the design and placement of the prop rod that holds the hood open, making sure it's easy to use and secure, are all ergonomic considerations. Some cars have gas struts now, which is much easier.
True. And what about refueling? That seems like it should be pretty straightforward.
While it might seem simple, there's still ergonomic aspects to consider. These include how easy it is to open the fuel door. Is the release obvious? The design of the fuel cap, is it easy to grip and turn, especially in cold weather? Although capless fuel fillers have actually solved a lot of those issues.
Right. Those are nice.
They are. Also, how easy it is to handle the fuel nozzle, the force required to hold the trigger, and the posture you have to adopt while you're standing there refueling. Even the angle of the fuel filler neck can affect how comfortable the process is and reduce spills.
It's amazing how much thought goes into even these seemingly minor details. I guess even making sure you can easily find the oil dipstick in the engine compartment is an ergonomic consideration.
Exactly. Making those frequently accessed components under the hood, like the dipstick, washer fluid cap, oil fill cap, brake fluid reservoir, easy to locate and differentiate. Often by using bright colors like yellow or blue or distinct shapes, is a small but important part of making the vehicle user-friendly for basic maintenance tasks. Good labeling helps too.
Now, the book also touches on something called automotive craftsmanship. That sounds a bit more subjective than the very scientific topics we've been discussing. What does ergonomics have to do with how a car looks and feels?
While craftsmanship can seem like it's just about aesthetics or luxury, ergonomics plays a role in ensuring that the look and feel of the vehicle contribute to a positive overall experience for the user.
Okay.
In this context, craftsmanship refers to the attention to detail that enhances those pleasing sensory characteristics, how things look, how they feel to the touch, the sounds the car makes, even the smell, and, of course, how easy and pleasant everything is to use. It's about perception of quality.
So it's about more than just whether something works. It's about the whole sensory experience contributing to a feeling of quality.
Precisely. The book talks about something called the ring model of product desirability.
Okay.
The innermost ring is the basic functional design. Does it do its job? The next ring out is comfort and convenience, which is where traditional ergonomics really focuses.
Right.
And then the outermost ring is pleasing perceptions, and that's where craftsmanship comes in. How delightful is it to interact with?
Oh.
All three of these layers together determine how desirable a product is to the customer.
What are some of the specific aspects of craftsmanship that they consider in car design?
They look at things like the visual quality, how well the different parts fit together, the consistency of gaps and flushness between panels, the smoothness of the paint finish.
Fit and finish?
Exactly. The touch feel quality, how the materials feel in your hand, the texture of the dashboard, the feel of the switches, the softness of the leather, the sound quality, the sounds the car makes, both the good ones, like a solid sounding door closing or a refined engine note,
Right.
and the bad ones, like rattles or squeaks or wind noise. Harmony, how consistent the design language and the feel of operation feel across all the different systems in the car.
Okay.
And even the smell inside the car, avoiding unpleasant chemical odors, is considered part of craftsmanship.
How do they even go about measuring something as subjective as pleasing perceptions?
It's challenging, but they use a variety of methods. They might conduct surveys and focus groups to get people's opinions on perceived quality. They evaluate samples of materials side by side. They hold customer clinics where people can interact with prototype vehicles or competitor vehicles and give detailed feedback on what they like and don't like about the fit and finish and the overall sensory experience.
The notes mentioned a study that looked at the craftsmanship of steering wheels. What did that involve?
That study looked at a lot of different aspects of how a steering wheel feels and looks. They examined the feel of the rim and the spokes, the shape, the diameter, how soft or firm the material was,
Mm-hmm.
whether it felt slippery or had a good grip, the quality and feel of any stitching, and the overall visual appeal.
Okay.
People drove in, driving simulators with different steering wheel designs, and then gave their subjective ratings on these different characteristics. This kind of research helps designers understand what specific features contribute most to a feeling of quality and comfort when you're holding the steering wheel for hours.
So all these different ergonomic considerations we've been talking about, they're not just afterthoughts,
Yeah.
right? They're integrated into the whole process of developing a new vehicle.
Absolutely not afterthoughts. The book describes a typical V model for vehicle development.
The V model.
Yeah, it shows the process going from high-level requirements down to detailed component design and then back up through testing and validation.
Hmm.
Ergonomics needs to be woven in at every stage of that V,
Okay.
from the initial concept and planning through the design of the different systems and parts, all the way to testing prototypes and validating that the final product meets the goals.
What's the role of the ergonomics engineer at these different stages of development?
They're involved in design reviews early on, giving their perspective on how proposed designs will impact users based on ergonomic principles and data.
Mm-hmm.
They conduct test drives, often with specific evaluation protocols. They participate in market research with potential customers to get direct feedback.
Right.
They review data from customer complaints and satisfaction surveys from previous models to learn lessons. And as we mentioned earlier, they often create and update those ergonomic scorecards to track how the design is progressing against ergonomic goals and benchmarks throughout the program.
What are some of the specific tools and information that ergonomics engineers use during this process?
They use computer-aided design, or CAD, software extensively, often with digital human models.
Like virtual mannequins.
Exactly, like Jack or Ramses, to visualize and analyze how people of different sizes will fit and interact with the vehicle design in 3D before anything physical is built.
Okay.
They might build physical mock-ups or bucks to test specific aspects like seating comfort or control reach.
Mm-hmm.
They rely on databases of human body measurements, anthropometric data, and biomechanical data on strength and posture.
Right.
And they increasingly use computer-based vision models to evaluate things like how effective the headlights will be, how much glare they might cause, how easy it is to see the instruments from the eye ellipse, and even how reflections on the windshield might affect visibility. That veiling glare from reflections of the bright dashboard on the inside of the windshield can be a real issue sometimes, especially at night.
Veiling glare. Okay. Speaking of measuring how well things are working,
Yeah.
how do they know if their ergonomic designs are actually successful? What kind of performance measures do they look at?
Good performance measures need to have certain characteristics. They need to be relevant to the task you're interested in,
They send it.
sensitive enough to detect even small differences between designs, reliable so you get consistent results if you measure again, and stable over time. In driving, they look at a whole range of things.
Like what?
This can include how the driver behaves, like where they're looking, eye tracking, how they're moving the steering wheel or pedals, their physiological responses like heart rate or brain activity sometimes, how the vehicle itself is performing things like speed, acceleration, braking, how well it stays in its lane, and ultimately, the real-world outcomes like driver errors, near misses, and accident rates, although those are harder to measure directly in testing.
The notes mentioned standard deviation of lateral position. What is that, and how does it tell you anything about driver performance?
Standard deviation of lateral position, or SDLP,
SDLP.
is a way of measuring how much a car is weaving or drifting within its lane. A lower standard deviation means the driver is doing a good job of keeping the car centered and steady,
Okay.
while a higher value suggests they're having more trouble maintaining lane position. Maybe they're distracted or overloaded.
So more weaving means more workload.
Often, yes. Studies have shown that when drivers are distracted, for example, by trying to use a cell phone or interact with a complex infotainment system, their SDLP tends to increase, indicating that their driving performance is degrading.
With all the new technologies being integrated into cars, I have to imagine that measuring how much mental effort the driver is using their workload is becoming really important.
Oh, hugely important. Driver workload is essentially the total amount of mental and physical resources and effort a driver needs to use to operate a vehicle safely in a given situation.
Right.
It's become increasingly critical to measure as cars get more complex with all sorts of new features, especially information and communication systems.
Hmm.
Currently, car companies often use a combination of methods to assess the workload imposed by new technologies before they're released. This often includes things like temporarily blocking the driver's vision while they perform a task.
The occlusion technique.
Yes, that's one. Plus, getting expert ergonomic reviews and using various specific workload measurement techniques we can talk about. The goal is to ensure new features don't dangerously overload the driver.
What are some of the basic ideas behind this concept of mental workload?
Some key ideas are that our ability to process information is limited. We only have so much attention to go around.
Limited capacity.
Right. We have to allocate our mental resources to different tasks: driving, navigating, listening to the radio. And sometimes those tasks can interfere with each other if the total demand exceeds our capacity.
Okay.
It's interesting to note, as we said before, that a lot of driver errors aren't due to physical mistakes, but rather to problems with how we process information, attention failures, memory lapses, decision errors, often linked to high workload or distraction.
What are some of the specific ways they try to measure how hard a driver's brain is working?
There are several main approaches. We already talked about driver performance measures like SDLP.
Right.
If someone's driving starts to get worse when they're trying to do a secondary task, that suggests increased workload.
Right.
There are also subjective methods where they simply ask drivers to rate how mentally demanding, physically demanding, frustrating, etc. they found a task using standardized questionnaires like the NASA TLX.
That's it.
Yeah, it has 6 subscales: mental demand, physical demand, temporal demand, performance, effort, and frustration. Or another one called SWOT, the Subjective Workload Assessment Technique.
Okay, subjective ratings.
Then there are physiological measures. They can look at things like heart rate variability, eye blink rate, pupil diameter, even brain activity with EEG, although those can be complex to interpret.
Mm-hmm.
Another approach is to give the driver a standardized secondary task to perform while they're driving, like a lane change task or a memory task, and see how well they do on that secondary task.
Secondary task performance.
The idea being that if the driving task is taking up a lot of their mental resources, they won't have much capacity left over for the secondary task, so performance on that task will drop.
Right.
Finally, there are analytical methods that try to predict workload based on analyzing the steps involved in a task, like programming a navigation system, using established models or guidelines like SAE J2 or 365.
It sounds like it's not always easy to get a clear picture of mental workload.
That's true.
Yeah.
While there are many different methods, there aren't really firm, universally agreed upon guidelines on exactly what constitutes an acceptable versus unacceptable level of workload for driving safety.
Ah.
And each measurement method has its strengths and limitations. Subjective ratings depend on the driver's perception and honesty. Physiological measures can be influenced by factors other than workload. Secondary tasks might not perfectly mimic real-world distractions. It's often best to use multiple measures.
So after all the individual component design and testing, how do they finally put it all together and evaluate the ergonomics of the complete vehicle, from early prototypes all the way to the cars that roll off the assembly line?
They use systematic methods for evaluating the whole vehicle throughout the development process. It's an iterative process.
Oh.
This includes getting feedback from ergonomics experts during design reviews and hands-on evaluations, and conducting trials with actual users, potential customers in different settings.
Yeah.
That could be in controlled laboratory setups, on test tracks or public roads, in driving simulators, and even using specially instrumented vehicles that record lots of data, or through naturalistic driving studies where people drive cars equipped with data loggers in their everyday lives for extended periods.
Naturalistic driving. Okay. What kind of information do they gather during these vehicle evaluations?
They collect both objective data, things like driver performance measures we discussed, steering, braking, lane keeping, eye movements, physiological responses, and subjective data using things like rating scales where people give their opinions on comfort, ease of use, appearance, etc.
Rating scales.
Yes, different types. Simple numeric scales, scales with descriptive anchors, scales with midpoints, even magnitude estimation scales where people assign numbers relative to a standard.
Okay.
They also use paired comparison methods where people are asked to directly compare two different designs or features and say which one they prefer, and sometimes by how much. This helps rank preferences.
We've talked a lot about designing for a sort of average user,
Yeah.
or maybe the 5th to 95th percentile range, but people are so different, and cars are sold all over the world in very different driving conditions.
Yeah.
How does ergonomics account for this diversity?
That's a really important point and a big challenge. Designers need to consider the wide range of people who will use their vehicles.
Hmm.
Not just the typical height range, but also variations in weight and body shape, people with disabilities, and even people with specific temporary needs like pregnant drivers who might need more steering wheel clearance.
Right.
Older individuals are another key group who might have reduced mobility, strength, or sensory abilities like vision or hearing. The aging population in many parts of the world is a significant factor driving design changes.
Yeah.
They also have to think about the differences in global markets, things like fuel prices influencing vehicle size, how easy it is to park in crowded cities, the types of traffic and road infrastructure, all of which can influence vehicle size and design priorities. A car designed primarily for wide American highways might not work well on narrow European streets.
Yeah.
And of course, different countries have different safety and design regulations, and there are the added complexities of designing for both left-hand drive and right-hand drive markets, making sure controls are mirrored appropriately.
Finally, looking to the future, what do you see as the big trends and challenges in automotive ergonomics with all the rapid advancements in technology?
The need for good ergonomics, for understanding the human element, is only going to become more critical with the pace of technological change in vehicles. It's not going away, it's evolving.
Right.
We're seeing more advanced safety systems, things like automatic emergency braking and lane keeping assist. The development of automated driving features is obviously huge.
Yeah, automation.
Increasingly personalized in-car environments, maybe adjusting seats and climate automatically, and a huge increase in connectivity and infotainment options. Telematics, which combines communication, electronics, and information technology, is a key enabler here. We'll likely see things like real-time traffic updates, seamlessly integrated, information about nearby services, vehicle-to-vehicle communication.
All connected.
Exactly.
And how might the way we interact with our cars change in the future?
We can expect to see more reconfigurable displays that can adapt to different situations or driver preferences. Touch screens will likely get more sophisticated feedback.
Better haptics.
Hopefully, yes. More widespread use of voice control that actually works reliably. More functions integrated into the steering wheel or maybe even gesture controls. Systems that can monitor the driver's state, detecting things like drowsiness, distraction levels, maybe even impairment through alcohol or drugs will become more common, potentially intervening if needed.
Driver monitoring.
Yes. And vehicles will likely provide us with more and more information about their own status and the surrounding environment through sensors and connectivity.
What are some of the big research questions and challenges that still need to be addressed in automotive ergonomics?
Well, one of the biggest challenges is understanding and mitigating driver distraction as cars become more connected and offer more potentially absorbing features. Finding the right balance is key.
Right. How much is too much?
Exactly. We also need better ways to integrate the digital interfaces in cars with those digital human models and visualization tools earlier and more effectively in the design process to predict usability issues. Understanding how drivers perceive the quality and craftsmanship of these increasingly complex digital and physical interfaces will be important too. What makes a digital experience feel premium?
Yeah.
And continuing to use things like naturalistic driving studies, where we observe people driving in their own cars in their normal routines, will be crucial for validating what we learn in the lab and in simulators and understanding real-world behavior.
So to really boil it down, it's clear that designing a car is way more involved than just making it look good and go fast.
Much more.
It's deeply rooted in understanding us, the people who use them, in all our quirks and capabilities and limitations. Every single detail, from the curve of the seat to the font on the display to where you reach for the window switch, is carefully thought out, or should be, to try and make driving as safe, comfortable, and user-friendly as possible.
Exactly. And hopefully the next time you get behind the wheel, you'll have a little more appreciation for all the unseen ergonomic considerations that shape your everyday driving experience. Maybe you'll notice things you didn't before.
And it really makes you think, especially with cars starting to drive themselves more and more. How will our role as drivers evolve? What happens to ergonomics when you're not actively driving all the time?
That's the big question.
What new challenges and opportunities will that bring for the field of automotive ergonomics? It's definitely something to ponder.
Absolutely. The focus might shift, but understanding the human in the system will remain critical.
If you're interested in digging deeper into this fascinating topic, we encourage you to look for more information on human factors in design, or perhaps explore some of those SAE standards we mentioned today online.